Okay, hi students. So the purpose of this video is to give you a tour of the single photon interference apparatus, and you see it right in front of you here. It's kind of a long aluminum structure. As you can see, it's about 4 feet long or so, and I'll call it the tube or the tunnel or the channel or whatever, but it just sort of goes all the way down, made out of aluminum. It's very well built, and that's where all the interference happens. And let me just describe the relevant parts for you here. So on the near side of it, closest to us here, you can see some wires going in, a little bit of a control panel on this side here. Let me tell you what those are. So basically, when you run the experiment, you can do it two ways. You can do classic coherent light interference with a laser, and so you can switch this little switch to up for laser if you want, and just be sending a laser through a double slit the way you did in either optics or your lower division labs. And you can also switch it to the down position, which will generate thermal photons using a different light source, which is none other than a small incandescent light bulb. So lighting, very old lighting technology, not an LED, just the bulb that heats a wire and glows. So definitely incoherent thermal photons can be sent down the tube or the channel when it's on bulb. And the black knob above the switch is the brightness control for the bulb. The laser's brightness is always constant, but if you have it on bulb mode, which we will, you can control the brightness of the bulb with that knob. The wire going down here, this one here, taps off of the DC power supply, so there's power coming in on this black cable right here, and this one up here sends the DC power also to the other end of the tube where the photodetector can be powered for detecting photons from the laser. So that needs power, and it comes from that cable. And the cable right above it right here is a bit of a safety feature. There's a switch over here that if the cover of the device is lifted off while the single photon detector is on, this cable will detect that this cover has been lifted and immediately shut power off to the single photon detector to protect it, because obviously you wouldn't want bright rooms and a light to hit the single photon detector when it's all powered up and on and everything. And this sort of lid right here comes off, which I'll show you in the next video as I show you the internals. Okay, going down just a bit more, you can see two things in this frame. You can see this silver knob and that white box with a 0 on it. So what the silver knob is a sub-millimeter micrometer. It's a positioner. And when I turn the micrometer, the double slit, when I turn this, the double slit can be translated laterally, left or right, across the tube or the channel there. It allows you to center the double slit relative to the laser beam or the incandescent bulb. And there's also a mechanical aperture in there, which is sort of just a large hole, which just does a little bit of cropping of the beam, so to speak, before it hits the double slit. And that knob just allows you to center it relative to the center of the tube and the center of the beam or light bulb as that light's coming down the tube. The white box that you see is the single photon counter output. So you see that 0 on it. It behaves very much like the counter you might have used in a nuclear lab. You just set a time interval on it. In the moment it's set to 1 second. It counts how many single photons arrived at the single photon counter in that time interval and just displays that on the screen. That's where our raw data is going to come from in this lab. And you can see that LED flashing on it. That's sort of the time interval that's set at the moment. So when the LED is on, it's counting. And when it's off, it's displaying the result. And there's a bit of a dwell time in there to give you some time to write down the result or what have you. And so it's just sort of going at the moment there. Okay? So far so good. And at the far end down there, you can see a big box. And what's inside that big box is the single photon counter, the photodiode, and the aperture. So I will get to those parts of this apparatus in the next video.